will now illustrate the idea of the GQM method in a specific example. This example is actually taken from a case study out of a book on GQM, where you can also read it up, because the book is also available online here through this URL. The context of this was, again, an industrial project, namely a development project with a duration of about 6 years, 20 developers, implementation in C++. And the developers wanted to understand how good are they doing in terms of fault detection and what is the importance of learning for doing reviews and inspections. Again, this was an improvement situation, but the way you apply GQM are fundamentally similar if you do it for doing standard research, so to speak. So the first phase is always the planning phase. In that case, the project was led by an external GQM team, meaning it was not the developers themselves that came up with the GQM plan and everything. And the GQM team started with training the development team, meaning explaining the method, trying to make them understand what could they expect and what is expected from them to support the GQM process. Then there was a mutual discussion, because also there needs to be an understanding what can be expected. Is it really something useful to perform that? There were not so much changes that were planned, and it was specifically designed to measure reviews and inspections, meaning in the beginning it was not even clear what the focus will be. Yeah, but they thought, okay, the best potential here from an improvement perspective is to focus on reviews and inspections. When discussing that, they understood, well, reviews are performed for fault detection, but there's also a teaching perspective in terms of reviews. That's actually pretty common. So a lot of reviewing in industry is actually done also for onboarding of new team members, so they get a better understanding of how things work. In this organization, the review effort was limited to a maximum amount of 4 hours per member per week. And the goal was now to develop a measurement plan to better understand how good they are in terms of reviewing and how this is influenced by experience. With that, one could come up with the goal definition, and that was analyze the effectiveness of structured reviews for the purpose of understanding, because they just wanted to know where do they stand, with respect to the detection of faults and the learning ability of the technique, from the point of view of the project team in the context of this specific industrial project. So the questions that they came up with: what are the baselines, the rule of thumb for executing reviews? What are the characteristics of a document to get optimal effects of a review? What are the acceptance criteria for the quality of the document after a review? And are reviews a useful and efficient method for training new engineers? Yeah, so these were the questions that further characterize the goal. These are still very, very high level questions, and therefore they refined these questions in a further step. So for example, all of these 10 questions that you have here on this slide, they are sub-questions of only question 1. Just for remembering, the question 1 was, what are the baselines for executing reviews? And for example, which kind of faults are likely to be found in reviews focuses on the baselining with respect to faults, or how much effort is spent on reviews. Remember, there was an upper gap, an upper level, but that doesn't say that people perhaps used much less effort and so on. So these 10 questions are just baselining questions. Now, for these questions, metrics were derived, and we have here this list of questions that people derived, and that's again only for question 1. Similarly, one would go through the process to also refine the other questions, and then this will lead to additional metrics. Some of the metrics may be common across different questions, but not necessarily all of them. This led to specific measurements that were done, and please notice even something like a document name for review is in some sense a measurement. So this is a measurement on a very simple scale, but nevertheless something where data needs to be gathered, and therefore it is a measurement in our terminology. So these are these metrics, and all of that together led to a large set of metrics. You see here sometimes it's only one of these blocks is only referring to a complete set of metrics. So we have a total, it goes here up to 26, and then we also have one metric 99. So it's basically 27 different metrics that were identified. And many metrics are useful for more than one question. Like, for example, metric 1 through 7, they are relevant to question 1, 2, and 3. But on the other hand, some are only relevant to one of the questions. So this is basically the measurement plan and how it was derived from the goal, on the one hand, and also how it would later be exploited to understand things. The next step was data collection. There was a kickoff session, and then there was a data collection form that was developed, and that had in the future, meaning starting with this point in time, had to be filled out during the review. So here you get an excerpt of the data collection form. It was actually, or it contained actually more detail on that. This information was then gathered, and then finally the interpretation phase was entered. The results of the measurement were analyzed, corresponding conclusions were drawn. And what they got was reviews are efficient to detect faults. The reviews detect more than one fatal fault per hour. They detect on average 7.5 faults per hour. As only 3 reviews a week were performed, they only gave feedback like every 4 months, meaning collecting 12 data points and then giving the next result. Also, they've identified where are these issues coming from. System tests, unit tests, some of them were characterized as never or unknown, and as part of the feedback analysis, they understood that actually are probably more faults like field test or installation. More interesting is how did the data they gathered really live up to their expectation. So this diagram shows the review performance of a less experienced reviewer performing his or her reviews on the documents of either of a less experienced developer or on the documents of an experienced developer. And what they got was, well, they expected many faults to be found also by a less experienced reviewer in the code of a less experienced developer, but in reality they found very few. And actually they found the less experienced the less experienced reviewers found more defects per hour in the code of an experienced developer. Well, that was somewhat counterintuitive because one would expect that the less experienced developer makes many more mistakes and therefore many more can be found. But apparently something else was at play. For example, a better readability of code by an experienced developer or something like that. So that's an important result. Similarly, here for the review performance of an experienced reviewer, again, the expectation was a less experienced developer makes so many mistakes. These are easy to spot, and then we will find many faults per hour. But on the other hand, many only few were really found in practice, and more were found for an experienced developer. So these deviations are certainly something to look into, and that's one of the reasons why you really gather baseline. You want to notice if something such unexpected is happening. There are many potential explanations, like it could be that the less experienced developers typically make the simple developments, and therefore they do not do so many mistakes, or they just write so hard to read code that even so that there are faults in the code, nobody finds. But that is something that cannot yet be answered with the data that has been gathered, because there has not yet been data on readability or on systematic differences in the complexity of the problem. So that can be seen as a shortcoming of the data setup. And ideally, for a project like this, one would have asked the question beforehand, what if we found something rather counterintuitive? Because then the necessary data gathering to distinguish between such hypotheses for explaining such counterintuitive results could have been incorporated into the measurement plan. That's also something very important in research, especially if we cannot replicate the research, or if we cannot do it again or reconstruct missing data, then it's very important to also analyze experiments beforehand. What happens if we find data that is not like we expected it? Because in this situation, we need to plan beforehand for collecting enough data. And this, however, can be predicted much better if we start right away with these baseline hypotheses and also think about violations of these baseline hypotheses. So what were the conclusions for the development team from this data gathering? They understood experienced reviewers detect over 3 times more faults per hour than less experienced reviewers. That's a very important result. Experienced reviewers detect 2 times more faults per page than less experienced reviewers, meaning they spot more of the available defects, 2 times more, and they are faster, because in total they are 3 times faster. More faults are detected per hour in code developed by experienced engineers compared to code developed by less experienced engineers. Here, with the given data, we cannot say, is it because there's really more faults in the code of experienced engineers, or is there another explanation for that? Fewer faults are detected per page in code developed by experienced engineers compared to code developed by less experienced engineers. This is already an indication that actually a major reason for that is not that experienced engineers make more faults, because per page we actually found fewer, but that something else is in play. Okay, with that, here you also find the literature for this whole chapter, and we will discuss this further